the network and how it is, what it is and how to use it and all this. We are going to be projecting the screen here up on the wall so everybody can read it. And I'm surprised we got it working because we hooked it all up and it didn't work. And I went over to Joe KE0QA's house Saturday. We had it all working there. Brought it in here, it didn't work. Had a blown fuse and I don't know what all here. But it is up and working. So what we're going to do is probably spend the first hour going through some of the slides and then hopefully maybe getting to live demonstrations. And the way I view the class right now is we'll probably be talking about how to do all this stuff. We're done with the deep stuff, the protocol and whatever, but how to do all the things, how to use it, what's out there, demonstrating it, and then we'll probably have a week or two break. And then if there are enough people interested, we will have a couple of sessions where we'll bring in the different TNCs and the different software packages so you can see them in use. The reason we're going to take a break is this overhead projector has to be in Minnesota on the 17th, so we can't use it that week. And that video monitor is just too hard to read, so we'd rather project it on the screen so you can all see it. So we'll have the normal class for the next 2 or 3 Tuesdays, and then terminate like we've always done, and then if there are enough people interested, we'll go demo part of the class where we'll show all this stuff. So as we get further along here, we'll take a show of hands to see how many people are interested. Unfortunately, Joe, KE0QA, who owns most of this stuff, is out of town for the next 4 or 5 Tuesdays. So hopefully I can run all this stuff. I'm not a CAM type person. I'm more PK232 and all that, but I think we can survive here. And there's probably enough people in the group here that can lead me through it anyway if we get lost. Are there any questions on what we've covered in the last 4 weeks? Does anybody remember anything we covered in the last 4 weeks? We went fast, it was heavy.
I had one question. It wasn't a technical question. How do you spell packet?
P-A-C-K-I-T. 2 words. Go ahead.
Is there any kind of a directory of, what do you call it? Not bulletin boards, but you tied in pretty quick order here to that round table in Ohio. How did you know to do that? From fooling around with it, or what?
Fooling around with it, basically. We'll show you when we get into things here. You can set on a frequency and just turn on your monitor to see who's beaconing. And a lot of people beacon and say what is available through their node. I have some examples. I won't show them tonight because we won't get to that point, but I have an example where I left the monitor on and there's 2 stations that have access to DX clusters. These are where you tie into them and anybody that works DX hears DX, puts the message in. The solar flux is calculated for you. All these neat things if you're a DXer. So you learn a lot of this by just watching the beacons that go out. Now as far as around the Midwest, you can log into a local BBS on 05 called W0LJF, and he's got maps that show you all this stuff that's available. Okay?
I've done that, but that one that you tied in going cross-band over, was it Ohio, I think?
Mm-hmm.
And all of a sudden you were in a round table.
Yeah, that was where I happened to see an ID go out one day that says X space CWQSO for roundtables. So I did it, and I was in this bridge. So you'll see a lot of stations that beacon on HF to let you know what's available and how to get there. So that's basically how you do this. I think you'll see it as we go into it. Who's my slide projector operator tonight? Who's got the magic button? There you go. Okay, let's go ahead and start talking about the network, since there are no questions, which means you understand everything we've talked about and you'll ace the test at the end of this thing. Because see, if you don't pass the test, you owe us $200. Didn't Joe tell you that? Okay, next slide. Okay, basically this is kind of what we've been talking about for the last few weeks. You got 2 stations here, K6AAA and W6ZZZ, who have a mountain that's out of the way. And K6AAA says connect to W6ZZZ. He sends the SABM, remember the SABM, the connect request? W6ZZZ's TNC sees it, sends a UA back to K6AAA. We now have a virtual channel. Anything that K6AAA types or W6ZZZ types appears on the other end screen as long as it is error-free. Now, kind of a review here. If K6AAA types something and the info frame is sent to here, but it gets clobbered because of noise, W6ZZZ's wife is running the vacuum cleaner, because W6ZZZ doesn't have time for stuff like that when he's packeting. Right, Les? First things first?
You say so.
So anyway, K6AAA sends the info frame, but it gets corrupted. So the TNC here rejects it because it's not error-free. K6AAA sits there and he waits for how many seconds he has programmed into his frac. In other words, how long do I wait for an acknowledgement before I decide the other end didn't get it? Okay. Let's say his frac is set for 6 seconds. At the end of 6 seconds, he hasn't heard from W6ZZZ. So normally he'll transmit a receiver ready with the poll bit set. That says, hey, I need a response from you, poll bit set, saying, I demand an answer. Are you there? W6ZZZ sends a receiver ready back saying, yeah, I'm there, expecting frame 0. K6AAA then knows that his iframe 0 never got there because the station at the other said I am ready to receive from you number 0. So at that time, K6AAA retransmits the iframe number 0. Now let's say the vacuum cleaner corrupts it again. K6AAA sits there running his timer, and when he reaches the value that's set in his frac timer, he says, I've timed out, no response. Sends the receiver ready again with the poll bit set, which is demanding a response out of here, saying, what's your status? He says, receiver ready, still expecting 0. K6AA resends the iframe. And let's say it gets corrupted again because W6ZZY's XYL has a habit of turning that vacuum cleaner on at the wrong time. The point being is K6AAA will keep trying to send that information frame through until he reaches the value set in his retry. In other words, if his retry counter is set to 15, he will try for 15 times to get that through. At the end of 15 times, he will send out a disconnect saying, well, if you're there, I don't hear you, so I'm disconnecting the link. So the point is, the frac value in here determines how long I wait each time I send before I decide something happened and I resend. Retry is how many times do I try to do it before I give up. Now there's another timer in here, I'm not sure if Joe covered it or not because I was in and out last week, called the link timer. Let's say that K6AAA connects to W6ZZZ. And he says, hi, how are you doing? W6ZZZ says, oh, I'm doing fine. K6AA says, okay, fine, I'll see you in a bit. Now I do this with some friends in California every weekend on 20 meters. I set up several links to people in California, and we leave it up all day. I'll walk by the screen and I'll see one of them has typed something in, so I'll answer it. Later on, the guy in California walks in, he sees something on the screen, he answers it back. And then later on, I walk in, I see it, and I answer him. And I carry on a QSO all weekend with 3 different people. But I don't spend a whole lot of time doing it. I just walk in, I see something on the screen. In the meantime, what happens if the band fades out? Okay. There's a link timer in there. And default on most TNCs is 5 minutes. So if nothing's going on, these TNCs are just sitting there. Both guys are out having a beer, cutting the grass, whatever. Every 5 minutes, one of the TNCs will come up and say, receiver ready, pole bit set, are you there? The other one will come back with the receiver ready saying, yeah, I'm there. And the other one will say, well, okay, I guess our masters are out goofing off somewhere, so the link's still there, that's fine. 5 minutes later, one of them will receiver ready, the other will receiver ready back. If all of a sudden the band dies, we're on HF, after 5 minutes since the last retry, the link check, K6AAA or whoever does it first will come up and send a receiver ready. If he doesn't get an answer back, he'll try it again, depending upon the frac time interval. Then he'll try it again. He'll try it for whatever time is in the retry timer, and then he'll send out disconnect and hang up.
Is there a specific timer for that 5 minutes?
Yeah, it's called the link timer. Default on most TNCs is 5 minutes. What's neat about this is I come into my shack at night and I see that my links went down at 8:30. I say, oh, the band died at 8:30 to California. And I have a link up to Florida and it died at 10 o'clock. In other words, you can set up these links and these TNCs will sit here every 5 minutes unless you change the timer and check the link. And when the band dies, they will try and check the link the number of times set in the retry timer, issue a disconnect, go back to the ready state. So you can come in at night and look at your screen and see when the band died to different areas. It's a neat way to check propagation. Kind of fun. Les?
Would you touch just a little bit on the instance of where the packet got stolen at WRTX?
Oh. Why don't you cover that, Les? Because I was in the hospital then, so I.
About packets, otherwise I would. No, the Denver Radio Club had a packet set up at the Red Cross building here a couple of years ago. Christmas Day evening, somebody got into there and stole their radio equipment, the HF gear and the packet and all this. There was a little box in there that Bill put $900 worth of time in to build that little box.
That was 10 minutes worth. My time's expensive.
And it was still there. Even a thief wouldn't take it.
Didn't recognize art.
But this link had been left on 24 hours a day. Then the cops come in there, when, how long, and so forth. A long weekend, they didn't know when it had disappeared or, of course, who got it. They checked with Dave. Dave said, well, my machine heard this at a specific time, night before last. So the police knew exactly, or within a few minutes of what time the guy got in and took it. So it's one use, I guess, for packets, because it leaves a trail.
Catch him.
He didn't plug it in anywhere else.
Yeah.
This same guy, later on, was trying to steal equipment from a radio place out the comm center on 74th and Broadway, or 72nd Broadway. They linked these two parts together. That this guy that got blew away, he had a bigger gun. The sheriff had a bigger gun than he did. Is what happened. So he found out that they were linked, and then they went to the deceased apartment and found the radio club equipment still in his apartment, which is what you hear sometimes now on WRTX.
But the point is,
Don't even steal that control box for packets.
he knew I'd be mad once I got out of the hospital and got to him. But the point is, this stuff is so concise, we were able to tell the PD within about 5 minutes or so when the break-in, well, not when the break-in occurred, but when he unplugged our equipment. And that kind of blew their minds, that that we actually knew what was going on down there. Anyway, this is our basic configuration that we've been talking about. And one of the things, let me make one point and I'll pick you up. One of the things you'll find, particularly on HF, people will talk about how slow packet is. What you do is, let's say we're sitting on 14101. A lot of stations talking, a lot of nodes, a lot of stuff going on. You see somebody calling CQ, you want to talk to, you connect to them. Then you tell him, let's QSY to 140108 or something to get off time sharing. Remember when we talked about time sharing where different people transmit packets at different time and your TNC waits till the channel is idle and then it slips the packet in? Well, to get away from time sharing, you QSY to a clear frequency. Now, you do not have to disconnect this virtual link that we talked about and QSY. You just go ahead and QSY. Because you've got 5 minutes before your TNC is going to ask the other end if it's there. Okay? So all you do is one guy QSYs, the other guy QSYs, and then when you're close, if you're not sure, one guy might just hit a carriage return, which causes this TNC to start looking for the other guy. W6ZZZ, 0 beats him, and then his TNC answers, and then away you go. Okay? So if you're on HF and you want to do keyboarding, your throughput goes up dramatically if you get off the shared frequencies. In other words, you get on the shared frequencies, kind of like on 2 meters. You get on 733, you find somebody you want to talk to, and then you go to, 146.52 or something, so that you don't have to tie up the system and share time with other people. Do the same thing on packet. You don't have to disconnect, QSY, and then reconnect. You just go ahead and QSY. Most people just don't realize you can do that, and they sit there and try to QSO with somebody while you got all these other people and all these other nodes and all these BBSs all doing their same on the same frequency. And of course, you got to wait your turn. Okay, so.
Is the link timer the same thing as D-wait?
No, D-wait is when you come up, turn on the push to talk, and then you wait, and then you key your transmitter. Anybody know on the cam what your link timer is called? On the 232, it's a link. I should have brought the book in on the cam. I'll try to remember to do that next week, and we'd be a little more specific on that. I didn't know what Joe had covered in this area, so I really wasn't prepared to talk about that timer. I was just trying to review, because Mary talked about the 3 timers, the T1, T2, and T3. It's the T3 timer, whatever that was called. Maybe I have it in my notes here real quick. I don't want to get too delayed in this. Okay, on the 232, it's called check. C-H-E-C-K.
What is it called?
Check.
Check.
Check. Default is 5 minutes. I'm not sure what it is on this one. When we bring it up, I'll type the word check and see if it tells us.
Quick question, I wasn't here last week. What's the frac stand? What does that mean?
FRAC is frame acknowledgement.
Okay.
In other words, after I send out an iframe, how long do I wait before I decide that I'm not going to get a response and I'm going to retransmit?
Yeah, as long as you're starting to get a little bit into that, Bill, would you know the PK88 commands are going to be essentially the same as PK232?
That's what I'm told. I don't know that for a fact, but I'm told that. Okay. Most of the TNCs are pretty close. If they're not real close, they're close enough that you can relate it. Les, do you by any chance know what it is on the MFJ?
I have never used it, Bill, and I don't know.
Anybody else know what it is? Who has an MFJ that has the manual?
MFJ's check.
Check? Okay, it is check. Great. Why don't you, if you don't mind, bring that in with you for each of the classes so we can kind of relate to different. I've never used an MFJ, so I'm not familiar with it. I've played around with the cam. Anytime I've had to set it up, I get the book out and just go through it. It's no big deal, but I don't have it memorized because I don't use it.
Help you, Bill, if I bring in what cam, let you look at, or
Well, I had the manual on the cam.
read the machine itself.
Well, we got one down here. Joe gave us his. So, thanks, Les. Anyway, this is the simplest connection. Station talking to a station. Now, let's move this mountain down here and put it in the way, which most of us have a problem with. There we go. We have something that's called a digi sitting on a mountain. And a digi performs pretty much the same function as your FM repeaters. Except, as a generality, because there's always exceptions, the input and the output of a digi is on the same frequency. We have one exception called a crossband digi, and we'll get into that a little later on. So what is kind of neat about this is you don't need cavities. You don't need all that stuff. You don't have desense problems because you receive and then you transmit. So let's say the K6AAA wants to talk to W6ZZZ, but this mountain is in the way. He would type on his TNC connect, or C, W6ZZZ space V for via space N6 NET-1. That sends out the SABM that has the, remember we talked about the source address, the destination address, and the via address. This TNC is going to send the packet out. This digi up here is going to see that his call sign is in the via address. And remember, about 3 years ago, we talked about the has been repeated bit. If you remember that, this TNC is going to see that his address is in the via part of the address field of the SABM, and his has been repeated bit is not set. So he says, aha, I've never repeated that frame. Because if I had of, I would have taken that has been repeated bit and made it a 1. So he pulls it into the TNC, buffers it. Now, when the channel is clear, he retransmits it. And he sets the has been repeated bit. Now, W6ZZZ sees this frame come in where he is the destination address. And he accepts it. Okay? Now, and this is very, very important. Once this TNC sends out that frame, he clears it out of the buffer. In other words, if he sees a frame for him that he has not repeated, and it comes in error-free, there's an error in it, he throws it away, because he doesn't even know if the address is correct. It might be his address, but if it's got an error in it, then maybe it really isn't his address. Maybe that's where the error is. If the frame comes in error-free from AAA, he brings it into the buffer, and when the channel is clear, he transmits it out and he clears it out. All he does is he repeats it. Very important. So what happens when you're using a digi environment is when K6AAA says, you know, connect to W6ZZZ via N6 NET-1, the SABM goes out, the TNC does get it error-free up here in the digi on the mountaintop. When the frequency is clear, it retransmits it. Then he throws it away. W6ZZZ gets the SABM, turns on the connect light, gives the message to the screen connected to K6AAA, sends the UA back. Well, K0PGM out here happens to transmit at the same time and clobbers the UA, so it's got errors in it. This TNC throws it away. This guy's waiting for a UA. As far as this guy's concerned, he's sent the UA. Now we're sitting here. Finally, this TNC retransmits the SABM after the frac timer goes out. Gets clobbered by K0PGM again. Les can transmit a whale of a signal, but he can't hear worth diddly squat. So the SABM never gets into this TNC. This guy's wondering what's going on because as far as he's concerned, he's connected. He returned to UA. This guy's sitting here thinking the W6ZZZ is dead. Frac timer runs out again if the retry timer hasn't been exceeded, or the retry counter. Retransmits the SABM. This time Les blew a fuse, so he's off the air. The TNC retransmits the SABM. This TNC says, well, I guess he never got the UA, because if he did, he wouldn't still be trying to do a connect request. Sends the UA back, error free, gets in here. Frequency is clear. The UA here is transmitted here. The connect light turns on. The connected to W6ZZZ message appears. The point is, the end-to-end acknowledgement is between the endpoints. All the digi does is he repeats. He could care diddly squat whether the other end gets it or not. He just repeats. And you can see, if you had 3 of these digis in a row, the odds of a frame getting corrupted in between one of the digis is fairly high. And you'll be here forever trying to get from here to here. Okay? The nodes solve all this. You never want to use a digi unless you have to. There's a question back here?
Yeah, so as far as the W6A or K6AA and W6ZZZ are concerned, it looks almost the same to them as if they were transmitting without a digi either, except that they're going via that digi. In other words, the same kind of thing could happen if their signal could get tromped on by a list in the same way, and it would look the same if they're transmitting directly.
Exactly.
Now the other thing is, I was going to ask on that UA frame sent back from W6ZZZ. Is that that's going via? In other words, there's a via indicator in there. So
yeah, this TNC will see that, oh, this frame came in from K6AA via here, so I have to respond back via. So he sets up the same path. See? And what you're saying, if you're going direct and you get something clobbers your frame, you just retransmit it. But when you start going through digis, the odds go up exponentially. The more links you have, the greater the odds are that the packet's never going to get through. And then you got to start all over again and go through the whole chain. Where in nodes you don't have to do that. Now, any questions on that part of it?
Maybe not on that part, but if that digi isn't on the mountaintop and all 3 of these guys live in the same city block, am I going to get that message twice, or what happens? Or do I throw one of them away because it doesn't have the repeat bit? Or
I'm not sure I understand the question. In other words, this digi is sitting down here.
You can get them twice, yes.
If you have the monitor on,
The digi has that same problem. Hearing it twice. You'll hear it come in, and then he hears himself go out, and it'll appear twice on your screen.
if your monitor's on.
Yes.
If you don't have the monitor on, you will not see it.
Right.
I'm going to give you an example later on where you're going to see a digi in action. If you can hear, if you're going through 2 digis or through 2 nodes, and you just happen to hear both of them, and you have your monitor on, you'll see your message 3 times on the screen, but by how you read the screen, you'll know who's saying what, and I'll show you this in a little bit. But if you have your monitor set where you're only copying what's to you, you're not monitoring the channel, then you won't see this digi retransmit, because your TNC will see it, but he sees that the source is ZZZ. I'm sorry, the source is AAA and the destination is ZZZ, so he's going to ignore it because he says, well, that's not from me, that's from me. Does that answer your question? In other words, if you turn your monitor off, so you're not monitoring what's going on the channel, you're only monitoring what's for you, then the only thing you will see is whatever he types. Okay? So I type, how are you doing, ZZZ? And it goes up to here. This -1 retransmits it. My TNC is going to see that, but since the monitor is off, he's going to say, well, that's my message going there, so I'm not going to put it on the screen.
Oh, I guess I meant AAA sends it to ZZZ,
Uh-huh.
ZZZ hears AAA, send it out.
Oh, yeah, he will ignore it.
The digi, which one's it going to throw away there?
If ZZZ hears AAA, he's going to ignore it. Because he knows that there's an intermediate station that hasn't picked it up yet. See, when the packet comes into him, ZZZ, the has been repeated bit is set. So he says, okay, this station has handled the packet, so now I can go ahead and take it. If he sees this packet coming from AAA and it happens to make it direct, this TNC will look and he'll say, well, the digi hasn't handled it yet because he hasn't set the bit, so this is not for me, it's for him. Then the digi retransmits it. The TNC sees that the has been repeated bit has been set, so he says, oh, this guy that's him sending, so I'm next in line. So in other words, that's the way all the digis work. They all look at that, and here's the source, the destination via digi 1, via digi 2, and via digi 3. And they all look to see who has repeated that message last, who has set the bit. And if my address is here, but this has been repeated bit here hasn't been set, then I'm going to ignore it because I know he hasn't got it. Okay, so you actually set up a chain. I could say connect to W6ZZZ space V for via space digi 1, digi 2, and digi 3, carriage return. Okay, and if digi 2 hears it, he's going to ignore it because digi 1 hasn't set the bit. And if this guy just happens to hear it, he's still going to ignore it because he sees that all the digis haven't handled it yet. So that's how they control who gets the frame next.
Yeah, what is the difference now between this connection here and just a link on a node?
Okay, I'm going to get into the nodes next,
Okay.
and how they work and how you connect to them. This is the simplest way to relay right now, a digi. It's simple but inefficient. And we're going to get into the nodes in a minute, and then I'll show you how they work and how to use them. And they're much more efficient.
Is the operator sitting at the digi station aware of what's going on, and can he read the message even though it's not reading?
You're a good straight man. You're leading me into my next thing. When somebody uses me as a digi, I'm aware of it because I have a relay in my old 2036 and I hear it clicking. And I go, somebody's using me as a digi. Otherwise, I wouldn't know unless I went over and turned on the monitor. There's a command you can put in there which will allow you to see who's using you. Now, I was going to get into this earlier, a little later, but I'll get into it now. Not long ago, I walked into my ham station and I had the volume up a little bit on my HF rig because it's solid state, no relays. And I heard the volume periodically dying, and I glanced down there and my transmit light was going on. So I went over there and there's a command for your TNCs where you can monitor who's using you as a digi. And I turned it on, and there was a station in Germany digging through me to a station in France on 10 meters because they couldn't hear each other. The intriguing thing is my antenna's in the attic. See? But I did go and turn it on just to see who's using me on 10.
When you say via Digi 1, Digi 2, Digi 3, you don't really type in Digi 1, Digi 2.
No, you type in the call sign.
Type in the call sign, okay.
Yeah, I'm using digi for synonymous. In this case, he had to type C space W6ZZZ space V, or via if you like to type, space N6 NET-1, and if there was another digi, it'd be comma, and then N6 OAV-1, something like that. You have to define the path. In digis, you have to define the path. In nodes, you don't.
Alias works the same way.
Yeah, nodes also, digis also have aliases that you can use. And I'm going to show you some examples of how the ID comes up later on. But Les has a digi, and yours is LYS, right?
Right. It just saves you 2 strokes on the keyboard.
Right.
But then it comes back with the proper identification.
Mm-hmm. You'll find aliases very predominant. A lot of people use alias that suggest their location, like DEN is one we're going to connect to tonight, hopefully. OKL, or no, OKA, which is Oklahoma. OKCY, Oklahoma City. You'll see a lot of aliases out there. A lot of them try to use the airline designators if somebody hasn't already done that. You know, they stamp your bag NYC, and it winds up in LAX. Packet is better than that. That's like the guy that walked up to the counter the other day, and if you've ever traveled, you appreciate this. He walks up, sets down his 3 bags. He says, I want that one to go to LA, and I want that one to go to San Francisco, I want that to go to New York, and I'm going to Orlando. And the guy behind the counter says, I can't do that. He says, well, why the hell not? You did it last week.
I went to Hawaii, I was going to go to JFK.
Yeah, I went to New York one time, and I got a trunk that had Greek on it, and they caught my bag just as the cruise ship was leaving for Greece. Anyway, notice something interesting. We have a radio, a TNC. We have a radio and a TNC. We just don't have a terminal connected here, although we could. That says, well then, can't this guy be a digi? And the answer is yes. All TNCs can be used as a digi. Now, if a sysop for some reason didn't want you to use them as a digi, he can go in there, and there's a command. I don't even know what it is because I've never looked it up. But he could go in there and say, I don't want to be a digi, and turn it off. But most people say, if somebody can use my station, that's great. That's the beauty of Packet. For those of you that are like me, that are in a house that can't have outdoor antennas, or in an apartment, all you got to do when you're on Packet is be able to get to somebody out there. And once you get to them, you're home free. You can go anywhere you want. Okay?
FJ has digi on and off.
Digi on and off? I think that's the command on most of them. I've never had occasion to look it up because I never really want to turn it off. And most people don't. I don't think I've ever come across a station where the guy turned it off. But that opens the whole world to you. For example,
Except those that you don't want to talk to you. Or I can enter W6OAV in a discrete slot, and anybody in the world can connect to me except OAV.
yeah, you can do all these fancy things with the TNC if you really want to be nasty. If you're an old AMer and want to be nasty, you can do all kinds of things. You can say who you don't want to connect to you, who you don't want to digi through you. I mean, you can really be an old grouch if you want to on Packet. But anyway, the point is, that's the neat thing about Packet. You can sit there with an indoor antenna or low power, and if you can get to anybody, you're home free. Give you an idea, those of you who get the round table, you've probably seen the, oh no, that's in the next one, isn't it? Okay, you haven't read this. This is a preview of next month's article. Give you an idea of some of the things you can do. Not long ago, I was connected to a guy in New Jersey on 15 meters, and he had 2 kW, a 6-element beam up 140 feet. I went, wow, sure beats my dipole in the attic. Must be really great. I said, you must do well in Europe. And he says, well, yeah. I says, I do great. He says, in fact, I'll tell you what, he says, the XYL wants me to go to the store with her, so I'll tell you what, I'll swing my beam around, point it to Europe, go ahead and use my station. So I sat here with my little 100 watts indoor antenna, digi through him, and I worked the world. It was just like I was at his station, you know, with this giant system. See, and that's why we put TX on the air. We got that beautiful station down there, and we said, well, why not put a Packet station up there, and then people can sit there and come into it and then work the world with that big tower we had and the big beam and all of that. So the fact that anybody can serve as a digi opens the whole world to you. There's a guy that lives about 1.5 miles from me, and he's always going through me. And he's just got a little quarter wave sitting on the refrigerator in a condo, and he gets to me and then goes to the world, and he works all over the place. So that's one of the neat things. You can use everybody else's station, everybody else's electricity.
It sure helps with RFI.
Oh, I know. You betcha. So anyway, digis are neat. They are inefficient. And even nodes can be used as digis. But you don't want to do it because it's inefficient. But yet we got people that continually do it because they don't realize what it's all about. Any questions on this? Okay, let's go ahead to the next slide. And we have changed the station on the mountaintop. It is now a node. And there are various kinds of nodes out there that we're going to talk about here in a little bit. But a lot of nodes are nothing more than a TNC where you change an EEPROM. Okay? Other nodes are computers. There's all kinds of nodes. But the simplest node is where you take a TNC and just change a chip. Now, can we focus that a little bit more?
Slide is warped and probably
There we go.
do better when it.
Okay, well, focus in the middle, I guess, then. Thank you. Now, K6AAA says C space N6 NET-1. I want to connect to the node. The node responds to the SABM with the UA. I now have a virtual link set up from here to here. And we're going to give all kinds of examples of this later on. Then I tell the node, I want you to connect to W6ZZZ. So the node sends out a SABM. W6ZZZ answers with a UA. The node then tells me, link complete. Now I type something and it comes up to here and I get an acknowledgement back. Now it's sitting in this buffer. Now the node transmits to W6ZZZ. Well, it's been 3 hours since our last example, and Les finally figured out he blew a fuse, and he changed the fuse, and he came on the air, and he corrupted our packet. ZZZ didn't get it. Okay? The node times out. He's got a frac timer and a retry timer and all the rest of that. The node retransmits the SABM and then gets the UA. Well, we've already done it. He sends the iframe, gets the acknowledgement back, and then he acknowledges back to here. The point is, when you have a node, I send the information to the node, he tells me he got it. Now it's his job to get it through. Okay? And then he'll get it through. And then when the answer comes back, he puts it in the buffer. Now it's his job to get it through. We're not concerned with end-to-end acknowledgement now. Each link is responsible for getting the packet through. So if I got 5 of these guys chained, and I send information to node 1 gets it to node 2, node 2 gets it to node 3, node 3 sends it to node 4, and K0PGM corrupts it, node 3 will just retransmit it to node 4, and then node 4 will send it to the end guy. I don't have to tie up all these links trying to get it through from an end-to-end basis. Okay, so when you use digis, you're acting as end-to-end, and if it gets corrupted anywhere between the ends, you got to start all over and go through the entire chain, tie up all the frequencies trying to get it through. If you got individual nodes, then each pair of nodes and each node and each end user is responsible for their end section. Once I get it here, I don't care. I'm done. It's his job to get it through.
Now, another difference isn't it that the operator doesn't have to type V for VIA to get it through on a node, correct?
No, there are different ways of doing this, and we're going to get into it because there are different kinds of nodes. In this case, all K6AA did was connect to N6 NET-1 and then tell him to set up a connection to him. There are certain nodes, for example, where, let's say I want to talk Salt Lake City. I'd connect the local node and I'd say, connect me to Salt Lake City. And he'd figure out how to get it there. And then once I was there, I'd tell him, okay, now tell Salt Lake to connect to so-and-so. There are other kinds of nodes where I have to actually know the path. And we're going to go through all these examples. So there's automatic nodes and there's manual nodes, and there's advantages and disadvantages to both.
You could also tell Salt Lake to connect you to San Francisco too, couldn't you?
Yeah.
I have a situation where I can't connect to WGLN-7. Would it be better for me to connect to WOTX-7?
Right.
Or would it be better for me to go through less to get to WGLN?
Pardon me?
TX is on 01.
Yeah, he's on a different frequency.
That's true.
But the point is, if you're having trouble getting to a node, you're still better to connect to a node, tell that node to get to the node you want to go to, rather than going through a digi. Because anytime you go through a digi, now you got end-to-end responsibility. And to give you an idea, they ran a test in California where they had 8 digis set up between 2 stations. And they had a computer keeping track of how many packets got through and how long it took. And then they turned right around and they set up a connection where they went to a node, to a node, to a node, to a node, and then sent the same traffic, and the throughput went up almost 900%. 900%. I've kind of experimented. I've gone like to DPK, which is in Pueblo. Go to Denver, Colorado Springs, which is on COS, which is on Pikes Peak, and then DPK, which is in Pueblo, and then to somebody. And trying it through digis, you sit there and you retransmit. All of a sudden you get an act, and then you retransmit, and then you retransmit. You go to node, you just, it's gone, and then you wait, and then pretty soon here comes the answer back. There's just no comparison. Les?
It'd be better if you're talking about getting out of the TX, go through the chunks.
Well, yeah, if you're having trouble getting to TX, you might try WS0O.
TX line, I can't get
Oh,
WGLN.
okay, well connect to TX and then tell TX to connect to WG0N. See, one of the things you'll find on Packet is you'll have this signal, this 700 over S9, and you cannot connect to it. Cannot connect to it. I have one like that. It's over the hill from me, and I cannot connect to it, but if I stick a piece of wire in the back of the radio, I can connect to it fine. You have what's called phase distortion multipath. You see it on TV sets. Well, it just tears Packet up. The fact that it's strong doesn't mean diddly squat. It's how clean it is. And once you get used to reading a tuning indicator on your TNC, you can get an idea of phase distortion and multipath and all these kind of things. When I run my QSOs to California, I can always tell when the sun's acting up because all of a sudden I see phase distortion, and he can be 40 over and it takes me 10 times to go one packet through. And I can tell there's something going on in the sun. So signal strength is meaningless in Packet. It means a lot in voice, but not in Packet. Dick?
Turn your set on, you let it warm up, and type an M herd,
Mm-hmm.
and you get your list. How do you know which is a digi and which is a node?
Well, you really don't. For those that are wondering what an M herd is, when you have your TNC sitting on the frequency, you can do an MH command, which is monitor herd. And it will list out the last, depends on your TNC, I think the 232 is about 15 calls. It'll list out all the calls that's heard on the channel. If there's an asterisk behind it, it meant it heard it direct. If there's no asterisk, it meant it heard somebody talking to it. Okay? Now, as far as digis, the only clue you have is if it's got an SSID. You know, most people don't use SSIDs, or if they do, it's a -15 or a -14. It's in that range. If it's like a -1, -2, -7 in the lower range, you can assume it's either a BBS or a digi. But that's about the only way you can tell. Because all the MH list does is just give you the call that it heard. And I have come up, you got to be careful on SSIDs. The other day, I accessed a friend of mine's station via his phone line, like I can do my own. I changed his call to my call. I connected to W0TX, and every time W0TX would answer, I'd get disconnected. I'm going, what the heck's going on? And then all of a sudden, this bolt of lightning hit me in the head. I was going out as W6OAV out of this station. TX would hear me and respond back. My station at home would say, hey, TX, what are you sending a packet to OAV for? We're not connected. He would send the DM command. Remember the DM command? And TX say, oh, okay. And it would dump me. So then I got smart. I said, okay, my call, W6OAV-1. So now when I came out to TX, it answered to -1, and my station home was sound asleep. So then I went from TX to WG0N, got disconnected again, turned the monitor on, and WG0N was taking the SSID-1 off. So when WG0N responded, he was responding to OAV-0, and my station home go, what's going on now? DM, and the whole chain would go down. So you got to be very careful on this stuff. the SSIDs. But that's the purpose of SSIDs, is to have different stations with the same call. But you got to be very careful when you do that.
So it's nice to have a wife for the call sign.
Yeah, there you go.
Would you just repeat what you said about, didn't you say something about certain dash numbers up to a certain point, what generally means something, and then...
Yeah, a general rule of thumb, and a lot of sysops change this, unfortunately. Let's say that we're sitting here with our monitor on, and we can see all these guys. We'll see K6AAA issue a connect request to SABM to N6 NET-1. We will see N6 NET-1 send a UA back. We will see AAA say connect to W6ZZZ. We will see up here K6AAA-15 connect request. TNCs will normally, if there's no SSID behind the call, it will put a -15 behind the call. Because in the example I just gave you, if he put out K6AAA connect request here, that's going to confuse him. He's going to say, who's doing that? That's not me. So -15 comes out. You will see W6ZZZ sending a UA to to K6AA-15, and then you'll see this call sign sending a packet back to K6AAA. So that's why the node will put a -15 on the call to keep this half separate from this half. Because let's say he did not do that, and let's say that K6AAA could hear ZZZ because he's running a megawatt. He's a California kilowatt. If he were to answer to K6AAA and we didn't have the SSID, this guy would respond and this guy would respond, and that'd be confusing. So he's responding to -15, K6AA-15, which means that even if this station can hear it, he's going to ignore it because his call is AAA, not AAA-15. Now, let's say you have two nodes. This will go out as AAA, AAA-15, AAA-14. If a node sees a -15 on the call, it will, or any SSID on a call, it will decrement it by 1. So theoretically, if a guy comes into you, connects to you, and you see that it's W6OAV-13, you could assume he probably went through two nodes to get to you. Now, unfortunately, some of the sysops change some of the parameters in the nodes, and some of them just take the SSID off. Some don't. You know, it's not uniform, but the general rule is when you go to a node, your call will go out with a -15 from that node. If it goes to another node, it'll be a -14, another node a -13. It's kind of interesting. I've gone all through the country and connected back to myself, and then hit stuff to time it, see how long it takes, and I've come back to myself -3, -2, -7.
When you're responding back on something like that, then you go ahead, you need to use the same one that the last node gives you, right? Say if you came in on, there was 3 nodes or something, and the last node sent W6ZZZ's transmission to you, and it came out as -12, then when you send your message back...
In other words, what your question is when a node connects to you and it's got a dash number on it,
Yeah.
you're going to respond with that call with the dash number on it.
Yeah.
That's correct.
Okay.
Yeah. That's the same as the path. I'm sitting there and this connect comes into me. If it's got a via 6 digits, I'm going to respond via the 6 digits. I'm going to take the reverse path back. And the SSID is part of that reverse path. So if it's 3 digits and an SSID, I will respond that way when somebody connects to me. I just take and look at the path and just ship it in the reverse direction.
Now, when the called user responds, say you've gone through 2 nodes, does node number 2 add an SSID number back?
No, he maintains the same one. So from here,
13.
if we had 2 digits, it would be back to 14, back to 15, and then back to no SSID. So the reverse path is just the reverse.
That's what I'm asking.
Yeah.
He adds the second node.
All he knows is his -14 if we had 2 nodes. So he sends it to -14. Now the node here knows that he's got to send it to -15. And the node here knows that this guy has nothing. And so, they take care of all the SSIDs that way. So what it amounts to is the path is set up. The equipment knows going the other way, it's just the reverse. Any questions on that one? Okay, now, this type of node, I have it labeled here as NetROM. And I'm getting ahead of one slide that's going to come up here, but there are 3 common nodes and then a bunch of not so common nodes. NetROM and VNet are synonymous. And then you got K nodes, and we're going to define those a little bit later on.
That was NetROM and what was
VNet. VNet.
THE?
THENET.
What was the next one then?
VNet and NetROM are kind of the same, and then K nodes.
Okay, no.
Those are the common ones. There's some not so common ones, and we'll cover those in a bit. Now let's give a quick example of this. Can we go ahead and kill that light? See, I had the monitor on here. You recognize DMs and UAs and UIs? Here's a network node F and L. KQ0J-2 just ID'd. That's the node Denver. That's the alias. I can connect to KQ0J-2, or I can connect to DEN. Now, look at this line. Rather interesting. We have a call sign. It's a beacon F and L, asterisk, Fort Collins, IMSES BBS on 145.01. See the asterisk here? This node is up near Fort Collins, but we didn't hear WA7NWP beacon. We heard the node FNL repeat his beacon. UI, information frame. W0LJF-4, that's on Conifer Mountain. That's the VNet node. His alias is ARA4. I can connect to him, or I can connect to him. So I'm going to try that. I'm going to say C space ARA4. Whoops.
Are you on 01 now?
Yeah. Okay, I just connected to that node. Now I want to say C space W6OAV. Oh, I can't do that. I'm on 20 meters. I forgot about that. I didn't leave it on there. Let's see. Who can we connect to? I wonder if KE0... Can TX hear Conifer Mountain?
Yes, not a solid one.
KC0CZ. I'm going to try to connect to him. Okay, now if I had the monitor on, we should see, and we're going to do this later on because I don't want to complicate it, but we should see a connect request going out. There, I just connected to him. The connect request went out with KC0CZ-15. Now Bob is up in Brighton. So I go, hi, oops, Bob. Hope I'm typing right because I'm not watching.
Very close.
Now, I don't know if Bob's home or not. If Bob's not home, if he has his answer message on, most TNCs have an answer message on, which says, hi, I'm not home, leave a message in my mailbox. Or if he's there, he'll see the connect and he'll answer me.
Bill, do you have to put a space in between hi, Bob?
Well, you're supposed to, but when you're typing and not watching what you're typing.
Okay, that's just all I want to know.
See, Bob will know that that's the way I typed it because Packet is error-free. So I can't blame conditions on that like you could in RIDI. Okay, apparently he has his auto answer off. Now I can go back to command mode, Control C, and I can go to D. Whoops. Oh, this keyboard is different than mine. Control C, there's command mode, and then D. Now I'm sending a disconnect packet. The UA came back, and my TNC said there. Look at that. What's Joe doing on here? Oh, his station's on. He's gone, but if I'd known that, I'd connected to him. But there's KE0QA-14, so he's going through 2 nodes to get to Bob.
Now, Bill, do you have any way of telling that your message, "Hi Bob, just demoing Packet for class," was or was not corrupted going up there?
Yeah, because number one, if ARA couldn't have made it, he would have said retry it out, disconnected.
Okay.
And number two, I would have normally turned the monitor on and I would have watched him transmit it. And if he only transmitted it once, then I know it got there. I may not see the UA come back from Bob because I can't hear him. If I see it go out 2 or 3 times and it doesn't go out anymore, I know it takes 3 times. So that's one of the reasons it's nice to have a monitor, because you can tell what the node's doing by watching his side of the conversation. But anyway, apparently Joe or Bob was talking to Joe, I'm not sure which.
What's the slash V mean after
That's
the
your
call?
cam, isn't it?
That says it's on the VHF port on the cam.
Isn't that your cam? Isn't it set up with Joe's ID on it?
Yeah. Yeah, the other day Bob was confused because he saw the call down here. Remember that connect request we had, I think it was last week? Well, he connected to Joe and didn't get a response, and he connected down here and got it busy. Then he realized that there was 2 cams going because he had 2 different calls, one with an ISS ID and one without. Okay, why don't we take a coffee break? An uplink and a downlink. We're going to get into, probably next Tuesday night, show you how to go into a node and ask it who's on the thing. And you're going to see terms like circuit, uplink, downlink, funny symbols, da-da-da-da-da-da. When I connect to this node, I'm sitting over here and I connect to the node and I ask who's on the node, it will show me that I have an uplink from here to here and a downlink from here to here. Uplink means that this station established this link. Downlink means the node established this link down. So I can tell who set up the connection. I can connect to this node, and I can tell this node, connect to him or connect to him. And if he has his users set to more than one, then I can talk to these guys. There's all kinds of ways of going into these nodes and asking them who they hear and who's on them and, and all that. That's how you find people. So you'll see the term uplink and a downlink. We'll have some examples of it, and that's exactly what it means. He set up the uplink, the node set the downlink up. Okay? Any questions on this slide? Oh, I'm sorry. I thought you had a question.
Going from node to node, you still have uplink, downlink?
No, that's circuits, and we're going to get into that. So right now we're just defining uplinks and downlinks. I think the next slide might show that. No, there we go. Okay, this slide represents a multi-port node. The slide we just had on there, AAA and ZZZ were on the same frequency through the node. Now here's a case where this may be 2 meters, this may be HF. This K node and its equivalent is basically 2 TNCs in one box. That's what this thing is here. This little TNC here is actually 2 TNCs in one box, dual port. A couple of weeks ago when we talked to the tanker, we sat here and went on 2 meters to WG0N, we told WG0N, go over here and call the tanker. This was the tanker in the Caribbean. That was on 18 megs. We were on 2 meters. That's a dual port node. Now, a lot of your TNCs, and when you are looking at what kind of TNC you want to buy, you got to define really what you want to do. The PK232, some of the MFJs I think are this way. The PK232 is probably one of the best TNCs around as far as filtering. It works the best of all of them. But you're either on HF or you're on VHF at any one given time. You can't run both simultaneously. You got a little button, radio 1, radio 2. The CAM doesn't have as good filters, but it's got a lot of neat things. It's got dual ports, and I can sit here, if I have a terminal, I'm a sysop, I can watch what's going on here, I can watch what's going on here, I can set up a link here, I can set up a link here all at the same time. CAM's got a lot of neat stuff in it. If you could take in my opinion, if you could take a PK232 and take the electronics and take the software of that thing and put it in one box, you'd have a whale of a modem and TNC.
Can't you also on that radio 1, radio 2 go into site internally and run that jumper wire and you can go out on HF on it?
No. No, because you only have one modem. And when you're on HF, it's a 1200 baud modem. When you're on VHF, when you're on HF, it's a 300 baud modem. And when you're on VHF, it's 1200 baud. Now, if you're on 10, you're allowed 1200 baud on 10. But it's just a different scheme. It's a different type of set of filters. It just wouldn't work that way. There was a rumor that went out one time that you could do that. And I saw a message come in on the local BBS that said, if you want to know how to do it, send a message to this guy. So I sent a message to this guy, which happened to be in Canada, and he sent one back saying, you're the 400th person that's asked me this. He says, I have no idea who's playing a joke on me. So I sent him one back, thank you for taking the time to answer all 400 of us. So that's been a rumor around, but no, you can't, because it's a totally separate scenario between the two ports. So anyway, this is known as a dual port node. A computer can simulate it. You can have 8 ports. We hope to have TX set up when we get to the Red Cross, where we'll have 4 or 5 ports. We're going to have a conference bridge. We can just log in and have a big old round table. BBSs, all kinds of neat things when we get the thing going. That's called MSys, which we'll talk about. So anyway, this represents a dual port. Now, what I do here is I connect to this thing, and I ask it, and we're going to show you examples probably next week, who are you hearing? And it's going to tell me who it's hearing on 2 meters. It's going to tell me who it's hearing on HF or wherever this is, UHF, but it's going to tell me. If I want to connect to somebody on the same frequency I'm on, I would type to this TNC and say, connect to this station. If I see somebody over here on the other port that I want to talk to, I would say X for cross connect, call sign. So in this case here, K6AAA is on HF, ZZZ is on VHF, ZZZ connects to the node, says who are you hearing, and it says I'm hearing these people on HF, I'm hearing these people on VHF. ZZZ says, whoa, I want to talk to this guy. So he goes X space for cross connect, crossover, and connect to AAA. This node will send a SABM, get the UA back, pass the information over, and send a message down here in iframe saying, link made. Now anything I type goes into here, is ACT back, nodes, put over here, and then he works on getting it here, gets the ACT back.
I think I know the answer to this, but I want to make sure. If I'm sitting here and I am working the node that's got the dual port there, I don't need a dual port
No.
TNC myself, right?
No, because you're just setting up a link,
Yeah, okay.
through your radio to this guy. So when you connect to this guy and get UA back, it doesn't make a difference who he is. no matter what kind of system you got on this hill. So I see space, whoever this guy is, and he sends you a UA. And then he'll send you information saying, I am a CAM, I am an MSYS, I am a G3 PYQ node, whatever that is. There's some, it's an English node. I'm a whatever. And most of these things have a help screen, and we're going to show you that. If you don't know how to do it, you type /help or question mark, and he'll download saying, well, if you want to do this, do that, and da-da-da-da-da-da.
They don't all tell you that, though, because you can connect to the node and it'll just come up connected, and then it'll be...
The NetRAMs and the DNets are that way because they're very simple.
Yeah, then you have to just type...
Yeah, we're going to go through all the different things you do on those. Those are very simple nodes. They don't give, although you get a help menu. Or you get a command line.
Just get a command line.
Yeah, you get a command line. We'll show you how to do that. But anything that's sophisticated, particularly these packet switches and some of these funny things, you can type a question mark or /help, and he'll download all kinds of stuff to you.
Earlier, did you say that the dual port nodes are called K-nodes?
That's the most common. That's the CAM. They came out with it first, and so a K-node is a CAM. But there are all kinds of systems out there that emulate dual port, 3-port, 5-port nodes. There are some nodes you connect to, and you can go out on about any frequency you want. Some of them get pretty sophisticated. But the CAMs were the first one to come out. They're the simplest. They're the cheapest. And then when you get beyond that, notice when we run the MSYS node at TX, it'll be on one of these. Be on a computer.
If you have more than two frequencies you're tying in with, I think you said TX did.
TX has got 2,
Oh, just two.
Just 2 right now. We will have more later on.
Do you have multiple TNCs, or are there...
Yes, you have to have 1 TNC and 1 radio. Well, you have to have 1 TNC and radio per frequency, or your computer port has to emulate a TNC to a modem to a radio. There are boards that go into your computer that emulate a TNC, and then you just tie a modem on it. There are some boards that actually even have the modem built in. So you just plug the radio right into your computer. Like everything else is getting complicated. There's so many different versions coming out. What do they call it? DRC boards? DRSI boards, I think it is?
Yeah.
I've never flew with one.
Well, isn't that AEA board that they advertise? Shows it as a plug-in board. It's the whole thing for packet.
AEA?
Yes, it advertises.
Oh, okay.
That's PK232 on a
plug in.
board that plugs in.
Well, that's why it doesn't have...
Oh, okay.
Other than
Okay, I wasn't aware of that. Okay. But anyway, basically, yes, see, here's the 2 TNCs are actually in one box in this case, but they are 2 TNCs with 2 radios. Question? Okay, next slide. Basically, nodes provide store and forward. Remember, that's where you connect to a node, you tell the node to connect somebody, you send information to the node stores it, and then he gets it there for you. Once he tells you he's got it, you're out of the picture, your job is done. Store and forward. Adaptive routing. Certain nodes, basically NetRAMs and DNets as a generality, have what's called adaptive routing. In other words, I can connect to DEN, and we're going to show you examples of this next week. I can connect to DEN and say, connect me to Salt Lake City, and he'll figure out how to get you there. And he may have 3 ways to get you there. He may know that he can go to Steamboat, to Dinosaur National Park, to Snow, to Salt Lake, and if Steamboat happens to be down for some reason, he knows he can go to Glenwood Springs as a backup route to Grand Junction, then over to Dinosaur National Park, and then over. Okay, I'm going to show you examples of all this later on, but it's called adaptive equalizers, adaptive routing. Certain nodes know how they can get you to a certain location. Primary path, best path, secondary, third quality, whatever.
Bill, when you say Salt Lake City, you're putting a call on there too, aren't you?
No, I just say C space SLC, because I know that's the alias. Because I can't remember calls, but I can remember aliases. Some of you younger guys can remember calls, but that's beyond me anymore. But aliases, all nodes, most nodes have aliases. And I'm going to show you how to do all this next week. Certain nodes don't have it. K nodes don't have it. If I connect to that node, or if I connect to Dave, and I want to connect to the, well, let's back up the conference bridge that we connected to last week. W0TX doesn't know how to get there. It doesn't have this routing table built in that we're going to talk about. So I got to actually know how to get there. So certain nodes have automatic adaptive routing. Adaptive routing means if a link goes down, he says, oh, I can't get that way anymore, so I won't try. I'll take this out of my routing table. And at the same time, he says, well, okay, right now I know that my best route is through Steamboat. My next best route is through Grand Junction. And I may have a third route through Ski and down around that way. And they're always testing the routes, so they know the quality of it.
What's DEN?
That's the alias for the local NetROM node here in Denver. And we're going to we're going to work this node out next week, because we're not going to have time to get into it tonight. This is the thing I was just talking about, automatic routing. In the NetROM, VNet system, the NetROM and VNet are firmware that go in your TNC. It's an EEPROM. They basically work the same. There's been a lot of controversy. Software 2000 invented a NetROM, and then the Germans came out with VNet, and there's been a big controversy as to whether they pirated the software. But they work the same, basically. Yeah. Oh, yeah. Yeah. Certain commands, you'll notice there's a slight difference. Other commands, you wouldn't notice the difference. But they all sit there and do these special IDs. I don't know if you remember in the information frame we talked about the PID bit. Well, they send information frames with a PID bit. And DEN, which is the local node here in Denver, will say, I know how to get to all these guys. And COS hears that. He says, oh, Denver knows how to get these guys. I'll put that in my table. So if somebody here in Colorado Springs wants to get to those guys, I'm just going to ship them to Denver because Denver knows how to do it. And then Colorado Springs says, I know how to get to these guys here in the Springs in my area, and I know how to get to these guys via Denver. And Pueblo hears that, and he says, oh, okay. If somebody comes up to me and wants to talk to one of those guys that Denver knows, I'm just going to ship them to Denver because I don't know how to get to those guys, but I know Denver does. And at the same time, if lightning wipes out a node, and all of a sudden these special IDs don't go out, then the other nodes will say, boy, I haven't heard from Springs for a while. Are you there? No. Well, anything he knows, out the window. So it's adaptive, and automatic. 800% better throughput. That's reference to digis. There's a pair of guys. There's a guy here in Denver and a guy in the Pueblo. One's father and one's son. And I even called him up one day. I said, you know, if you use these nodes as nodes, you guys wouldn't be retrying out all the time. And I explained it to him. And I go up there and I see him. Retry, disconnect. You know. And it takes them an hour to get through 2 sentences through. And I'll go down to Pueblo, where the other guy is, and connect to somebody I know down there, and we just sit there and bang away. And of course, that ties the frequency up for you and I. These guys sitting there trying. So if you see somebody that's using a node as a digi, you know, you might diplomatically say, hey, I can tell you how to get your throughput up 800% by using the node as a node. Because see, you can use a node as a digi. I can say, in that one example, N6 NET or whatever it is, I could have, K6AA could have said connect C space WA6ZZZ via N6 NET. In that case, the node would just act as a digi. See, but the throughput would be terrible, because now that mountaintop is just sitting there passing things. He doesn't care whether the other end gets it or not. He's just passing them on. If you connect to him as a node, now he has to care.
So how do you connect to him as a node?
Okay, K6AAA would say connect C space N6 NET-1. The node would come back to him and say connected. Just like when I connected the DEN there. And then I'd say, okay, now C space WA6ZZZ, and now the node would be doing the node would say back to me, okay, I got your connect request, I'll take care of it. He sits there and he says connect, and then pretty soon WA6ZZZ, UA's back, and then the node tells K6AA, link made. Then K6ZAA says, "Hi, Fred." iframe goes to the node acts it back. My STA light goes out. Remember the light that says whether you have something in queue or not? It goes out because it's been act. Now the node is sitting there with, and he's got to turn out his STA light. He's got to get it to WA6ZZZ. That's like earlier. I connected to DEN. I said ARA. I said C space ARA4, and it said connected back, which told me that UA came back. And then I said C space KC0CZ, and we waited. And then pretty soon it said link made. We're going to do a lot of this on screen next week. Les?
If I understand it correctly, to simplify what Dick asked, if you connect to a node, your keyboard is then talking to that TNC, not your own.
Yeah, you're talking to the node.
To that TNC and not your own.
And then that node is also talking to the other guy.
Right.
See? So in the example there with the node, in actual fact, K6AA is talking to the node. And the node says, I got it. And then the node turns around and he's talking to WA6ZZZ and expecting a response from WA6ZZZ. And if he doesn't get it, he'll try again. I don't know this other than it just takes a little while for an answer to come back because they're sitting there on the other link trying.
So then if you're using NET as a digi, you type in via.
Right.
And if you're using it as a node, you type to that.
You connect to it. Yeah. If you type via, it could be anybody's TNC. It doesn't, anybody can be a digi. And via means if you hear it, repeat it. But don't expect, any acknowledgement. Via just says, if it comes in one ear and it's good, send it out the other way and don't worry whether the other guy gets it or not. Because the other guy is responsible for acknowledging it. See, so there's no, the ends of this chain are responsible. Whereas when you have nodes between the ends, now each link in the chain is responsible for his link. And they'll work at it till they get it to the next link. See? So you're not tying up 10 links trying to get something through. Right?
Yeah, can you may have already covered this, but can you sit there and connect to one node and then connect to another node and then send a command to both of them? In other words, try it through two avenues simultaneously to get to the station you want to get to. Okay. Now, are you using?
Yeah. In other words, I could connect to DEN on channel 0, and I could connect to ARA4, the other node, on channel 1 of my TNC, and then I could tell both of those to connect to same guy or different guys.
And those two nodes will be looking at you with two different SSIDs, correct? Okay.
Yeah, because remember the destination address of each of the two packets is different. So the fact that this goes to DEN on channel 0, ARA is ignoring it because the destination is DEN. And when you send one to ARA4, well, then DEN is ignoring it. And when either one of those send, they're sending to W6OAV. They're not sending to each other. So they're totally separate virtual channels.
You can try to get to San Jose via, say someplace in Wyoming and then someplace in...
oh yeah, I've done that many a times. I've set up 5 or 6 links different ways to see which one gets there first and dump the rest. And sometimes I've left 2 up in case one goes down. Oh yeah. That's just like Les has a message on his TNC. You probably haven't seen it, but I connected to you. I was on 20 meters this morning. I couldn't hit hit TX direct. So I went to St. Cloud, Minnesota, and then came back to TX on 20, and then crossed to 01, then crossed to 05, and connected to Les. In other words, I had to go, 1,000 miles out and back because I couldn't go 20 across town. That comes after we try to figure out what happened.
If I take and connect to DEN, I'm using it as a node now.
Okay.
Connect to COS.
Okay.
I'm using that as a node.
Right.
Now, if I say connect me to Salt Lake City and it uses the adaptive routing or the automatic routing and it goes through 5 stations, Are those being digied?
No.
Are they being noted? And how do you know past the last connect that I made that it's using 15 intermediate frequencies?
You have no idea how I got there. In other words, if you sit there at COS and say connect to Salt Lake City, it might come right back to Denver, where you are, DEN, and then go out that way because that's the route. KC0CZ just connected to us.
Timed out.
No, we just got to connect. Dash 15, so we know he's coming through a node.
But those will be nodal communications.
Nodal communications. The nodes talk at a high level, a very high level called level 3. And your TNC can't decode that.
Mine can't. Just send it back.
Right. But it doesn't make much sense to you, though, does it? Because what happens, you connect to DEN and you say connect to Pueblo. So DEN has to set up a link to Colorado Springs and then to Pueblo. And then somebody from Cheyenne says connect to Pueblo. So he comes down through Laramie, Fort Collins, Denver, COS to Pueblo. Now when the nodes talk to each other, there may be 5 people coming through DEN going towards COS. He takes a packet and he puts all those users in this one packet, sends it to COS. COS takes a look at it and says, okay, these 3 users, their information goes to DPK. These 3 users, they go to Haswell or something like that. So you've got multiple users' information in one packet, and that's called level 3. And if you hear a brap, nothing appears on your screen if your TNC is right, and then you see receiver ready. That was one of those level 3 packets. Now, if we had backbones, you wouldn't hear that, and we're going to show backbones in a minute here. Did that answer your question, Dick?
Yes, thank you.
Okay. Next slide. These are the most common node types. NetROM and NeNet basically are the same, and we're going to start off next week demoing how to run them. K-nodes are these, and then there's a lot of things that emulate K-nodes. And this will become clearer when you see them on the screen when we actually run them. Next slide. You'll hear some terms, we're not going to get into it very heavily. Level 1, Level 2, and Level 3. You've heard me talk about Level 2. In this protocol, when you talk about Level 1, that's the physical level. Remember the RS-232 we talked about, and the send data lead, pin 2, receive data lead, pin 3, and all that stuff? Remember the connector on the back of the TNC, back of the computer? That's Level 1. That's the hardware stuff. Level 2 is what's called the link. You probably don't remember, when we started this, I mentioned to you that I'm going to try not to say packet because it's really not true. Packet is Level 3. Frame is Level 2. So in other words, Level 2 is the stuff that goes on this cable between the computer and the TNC. And from the TNC to another TNC, or to a TNC to a node. The nodes communicate on a very high level called Level 3. They send what is really packet. It's a packet of information that contains many users' data, whoever happens to be coming through the node, going somewhere, plus housekeeping stuff, plus these routing tables and all kinds of stuff. Okay? So that's Level 3. You'll never talk Level 3 unless you're running some very sophisticated programs like TCP/IP, possibly MSys. So if you hear people talking about levels, that's your cable, that's what's on your cable, and that's what's out there in the network on the high level nodes. K nodes don't talk Level 3. That's why you have to know where your routing is and set it up, because they don't have Level 3 capabilities. Okay, next slide. I think we got about 2 more and then we'll call it quits here. In answer to somebody's question here about when people come through a node, how does it show up? Let's say I connect to this node and I say, who's on the node? Here's a case where K6AAA said connect C-space N6NET, got a UA back. Then he said connect me to N6NET-3, or maybe SLT, the alias, Salt Lake City. He tells this node, connect me to this node. Well, this node, through these adaptive routing table, knows that I got to set up a link through -2 to -3. So at this high level link 3 stuff that you and I cannot decode, this node says set up a level 3 link through here. So they do this. It's kind of the same thing, you know, connect me here, connect me here. You got it, you got it. When that happens, you'll say connected to this guy. Then I say, okay, connect me to W6ZZZ. This node says ACK. My STA light goes out. This node, via this node, through the node, not via, but through the node, because they're talking on a high level ACK, no ACK thing, individual links. Each node is responsible, or each pair of nodes is responsible for that link. The request gets here. If we were monitoring here on this frequency, whatever it is, we would see this node send connect request SABM from K6AAA-14. 1, 2, 3, dash 13, I'm sorry. 1, 2, 3, yeah, 15, yeah, 13. Dash 13. As far as this guy is concerned, this is K6AA-13 connecting to me. That's part of the call, dash 13. So he sends a UA back. This node tells this node to tell this node to send a link made here, connected to. Then anything I type here goes in, it's mixed in with all the other people who are coming in from different places. At this point, there may be some channels split off to some other node, some channels sent to this node, and then out to here.
The term 15 on the end of the call, K6 AAA, is derived from where?
In here. In other words, if AAA connected to this node and then said send out a connect request from this node, you would see his call going out, connect request from K6AAA-15. Or if AAA connected to this node, told this node to connect to this node, and then told dash 2 here to send out a connect request to somebody, now it would be K6AAA-14. Okay, so each node decrements the SSID by 1.
The slide should be 13 instead of 15.
Right hand.
Yeah, that's wrong. Never noticed that. Okay, now the point I want to make here is, again, if I log into this node and I say who's on it, I'm going to show that I have an uplink from this guy and a circuit to this node. So I know that this guy established the call and then set up a link this way. If I happen to connect to this node in this city and I say who's on it, I'm going to see that this guy has a circuit from here to there. In other words, a circuit coming in and a circuit going out. So I know that he did not connect to this node locally. He's somewhere else. It's a circuit. It's coming in from somewhere. If I connect to this node and say who's there, I'm going to show that K6AAA is coming in on a circuit from this node, and he's got a downlink. That make sense? So anytime I see a circuit that says it's going to some other node, if I have 2 circuits, then it's a node on each side of this node I'm on. If it's an uplink in a circuit, he came up and went out, and vice versa. Came in on a circuit, downlink. So that's how I know when I go into these nodes, I'm going to show you how to do it, to figure out who's on there and what mode they're in. If I see that I got a circuit going to this guy and a circuit going to this guy, I can figure out how to get there and then connect to them. And we'll go through that next week.
Can I connect to Net 2 and monitor? I mean, not just
No, you can't see what's going on because that's level 3 stuff.
Oh, okay.
No. Anything that comes out at level 2, if I'm sitting here, I can monitor this link, but I can't monitor that link because that's level 3. Unless you got TNC that's doing what it's not supposed to. Some of the early MFJs. And what happens is this stuff is like binary, and your bell starts ringing, your screen clears, locks up your screen.
Are the net ROMs, normally speaking, are they usually adaptive routing?
Yes, net ROMs and DNets are adaptive. There's about the only 2. No. MSys MSys resides in a computer. There's a G3 something or other. There's a packet switch software that resides in a computer. Those all have adaptive routing to them. We had a problem here one time where when I first turned TX on the air, I got the phone calls that I had screwed up DEN because it was showing routing tables that were full of garbage. And I said, it can't be. TX can't speak level 3. Well, Fred K0YUM had just turned up TCP IP in his computer, if you know anybody know Fred. And he had a glitch in there, and he brought down the network. But I got blamed for it because TX appeared in this garbage a couple times. See, so you got to be careful if you're running something at home that can talk to these nodes on the hill, because if you corrupt the routing tables.
If AAA connects to M6NET-1, it's an acknowledgement.
Okay.
After receiving that acknowledgement, if he sends a connect to M6NET-2, what happens?
It will do that, and it'll come back after it sets it up. It'll say connected, and then you can turn right around and say, okay, connect to -3. You say connect to -3, and it'll set up a link, and then come back and tell them we're going to do that because we have a section called exploring the network. How, do you want to figure out how to get Salt Lake City? We'll show you how to do that, and you can actually see. You can look at the routing tables and say, how would you get me to Salt Lake City? Oh, you do it that way? Okay, connect me to it. How do you get me to Salt Lake City? He said, well, that way and that way. Well, this is a better path. Okay, connect me to that one. How do you get me there? We're going to do that. Today I found a satellite link out of Illinois and went to California by doing this. Because I connected into Illinois and it said it could get me to Las Vegas. And I go, there's something shaky here. How do we do this? So I started doing, okay, how do you get me to Las Vegas? I went through 3 nodes and all of a sudden I had this satellite link and I was out to California. See, it's called exploring the network. I got an example here of what I call a 50,000-mile circuit to go about 400. Les can tell you this. I've gone halfway around the world to connect to him at times just to...
One time he went around the world and I was following him on my monitor and he lost me somewhere over Alabama.
And I've been a couple times when one time I was on the East Coast and the next thing I knew was on Mexico, and I go, now wait a minute, how did I get to Mexico? To this day I have no idea how I did it. Let's see if the next slide, we're coming to a break point here. Okay, the next slide. Now this is a little different. If you'll notice here, we have dual port nodes. We come up on 2 meters. We go out. This is called backbones. This is a real efficient way to do this. Because in the earlier slide, everybody was talking on 145.01, for example. So if you got some guys pounding the keyboard here, the node that we showed on the other slide couldn't talk to the other node because these 2 guys were talking. So we put the internode stuff on 220, so you could care less what's going on down here on 2 meters. It's not tying up these channels. Your throughput goes way up. And they're in the process of putting some 9.6 or 9600 bits per second backbones up and down the front range, and that's going to really speed it up, because right now, if you connect to DEN and you say connect to COS, and and Les and Dick are sitting there, talking about something, DEN can't get it through to COS until they stop. See, so it's really slow. So if you take the network stuff and put it on a different frequency, separate from your users, now the nodes can sit there and just pass traffic like crazy and not be tied up. So that's called backbones, and this is a good place to break. Next week, we will basically do this stuff. We're going to connect the nodes. We're going to ask it how it does things. Who does it hear? Da-da-da-da. We're going to do all this stuff. We'll probably do that next week and the week following. And then the week after that, I think it's the 17th, we probably won't do anything because this overhead thing here has to be in Minnesota. So we have no way of really projecting, and the video monitor is too hard to read. I can't even read it standing next to it, so I don't know how you could read it back there. So basically, I think we'll finish the class week after next, take a break, and if there's enough people interested, then we'll bring various people in here with their TNC and their software and this overhead and have them demo like Packet Gold with the 232 and the PK88, which is great. That's what I use. Hostmaster, Dave WG0N, who has the node that we use to talk to the tanker, is going to come down and demo Hostmaster if there's enough people interested. And you can see the different software packages in action, PackRat, all these kind of things. We're using, the thing you've seen here tonight is just Procom Plus, if you're familiar with that. It's just a terminal emulation program. So we're using this as a dumb terminal, which you saw up here tonight. And next week, probably the next 2 weeks, we're going to use this as a dumb terminal. It could be just a regular old terminal instead of all this stuff. So the fact we're using a computer, don't let that scare you. You don't need all this to do what we're going to do the next 2 weeks. So we'll be canvassing you week after next to see how many want to come back, probably the Tuesday after the 17th, if you want to see the TNCs. It'll help you evaluate what the TNCs do. It'll help you evaluate the software packages that are available and the merits of all of them and all that kind of stuff. Okay?
Bill, before you put now, the backbones are talking about putting along the front range here. Are they going to be on UHF?
Yeah.
So on 440?
Yeah. They do that now with some of the BBS intermessage traffic, and that's another thing we'll do is log into a BBS and show you that. But the BBSs forward their message on some of the UHF backbones, because if they did it on the keyboard frequencies, you wouldn't get a word in edgewise.
How's that gonna work?